In this question, we're also going to calculate a change of momentum. We're told, find the change of momentum when a ball of mass 40 grams, travelling at 10 metres per second, rebounds perpendicularly from a wall with a speed of 6 metres per second. We've drawn a diagram. On that diagram, you can see that there is a wall. The ball is travelling towards the wall, and we know it's travelling towards the wall at 10 metres per second. It hits the wall and it bounces back perpendicular at a right angle. So the speed coming off the wall is 6 metres per second. Because we have two parts to this problem, the ball travelling towards the wall, then away from the wall, we need to define very carefully our direction. I've drawn on the diagram our unit vector I and unit vector j directions. The j direction is irrelevant. The ball is going straight to the wall and then bouncing straight off. The only thing that matters is the I direction. You can easily avoid writing the vector components in your answer. So if we consider the journey travelling towards the wall, we are told the ball has a mass of 40 grams. Now remember, when we're working out momentum, we need to use our units in terms of kilograms. 40 grams is equal to 0.04 kilograms. And we're travelling towards the wall at 10 metres per second. So if we want to work out our momentum from travelling towards the wall, then we have our mass in kilograms, 0.04, times 10, the velocity we were having there. So 0.04 times 10 is 0.4 kilograms meters per second. So that's travelling towards the wall. What we also have is the bouncing back off the wall. So again, this is going to be a calculation of momentum. What we can see is that we have momentum equals mass times velocity. We have the mass of 0.04, that has not changed. What has changed though is the velocity. Now our velocity is 6 meters per second. We're told that's a speed. So in terms of considering it as a direction, it is in the opposite direction to travelling towards the wall. So instead of writing it as 6 meters per second, we write it as -6. So going towards the wall at 10 meters per second was positive direction. Going away from the wall is the negative direction. Multiplying those together, we get -0.24 kilograms meters per second. So now we can work out the change in momentum. The way in which we do that, we've taken the final momentum, which was -0.24, and we have subtracted 0.4. That will give us -0.64. But we have taken the absolute value of that. The absolute value will give us positive 0.64 kilograms meters per second.